In our next session, we will talk about ESA operations. In particular, I'm going to discuss host and recipient access tables. Okay, so before the actual message processing starts, before ESA even considers the sender of a message, before it selects the policy, the device is gonna look at the connection more of like from level 4 perspective. It is gonna be looking at the TCP flow characteristics to decide how to handle the session. So it's all about looking at the IP address of the connecting SMTP host using the RFC's nomenclature, or just SMTP server acting as a client in this case, looking at its IP address in order to perform what is known as double DNS lookup. And double DNS lookup is basically a series of DNS requests generated by the appliance in order to check the DNS information for the connecting client. So there are going to be actually two queries what ESA would normally send, asking the DNS server to verify the sender of the message. I'm going to visualize that. Let's say that we have our SMTP host, or just a device which is going to act as a client in the session. So this is going to be an incoming connection to our ESA. And I'm going to say that SMTP host uses IP address, let's say X. For simplicity, it's going to be X, not the actual number. And remember that we are talking about a TCP connection level. So it's a TCP session. We assume that we use the default port 25. On this listener here, we look at the source of this IP packet, of this TCP packet, trying to figure out the IP address. And as I said, in our case, the actual address is X. And now what ESA is going to do in the first step is that it will perform a reverse lookup, trying to figure out what's the name associated with the connecting IP address. So this is going to be the pointer record, what we will try to retrieve using this lookup, which is supposed to give us the FQDN of the connecting SMTP host. Okay, so let's say that the result of this lookup is the following FQDN X. Of course, what could potentially happen is that we didn't get a reply in this case, like if the X was not associated with a FQDN, but the assumption is that those lookups in our case will succeed. There's going to be another lookup at this point, still performed by the ESA, but this time we will try to do the opposite. We will try to figure out what's the address associated with our FQDN returned in the first step. And even that it may sound like these two will always be the same, it's actually not necessarily going to be the case. You will see a lot of examples where the IP address is mapped to FQDN, let's say 1, but when you do the address lookup on the FQDN, you will get a different IP address. So something like this could potentially happen, and because of that, we do the lookup in both directions. So the goal here is going to be to figure out if the result returned in the second step is the same as what we checked in the first step. Because if these two are the same, we assume that the sender is verified. But as I said, it doesn't necessarily have to be the case. You could have a situation that one of the lookups fails, like when the server was configured with just one of the two records, or maybe the results will not match, in which case the sender would be deemed as unverified. And this technically doesn't break anything on its own. but this information can be then potentially used in the sender definition, in the sender group definition as one of the conditions. So this information is something that you will be able to use as you configure the ESA. Right, and this is exactly the first thing that ESA does on a new connection. Now, the second thing that is going to be performed on the backend is going to be a check of the so-called sender base reputation score, abbreviated as SBRS, which is a similar lookup to one performed by the WSA to figure out the reputation of a website. But in this case, we are more interested in the reputation of the source of the connecting SMTP server or just SMTP host. And now the way that ESA will figure out the reputation is that it will look up the connecting IP address in the sender base, and the Cisco sender base is going to reply giving ESA a number which is a decimal, something in the range from -10 to +10, where -10 is almost guaranteed to be a spammer. So this is a really bad reputation, where when you get something close to +10, it means that this is a trusted, legitimate, well-known, reputable sender. Never assume to source any type of spam. So this stuff, as you just guessed, is going to be used primarily to distinguish between junk and legitimate email senders. Okay, and this information collectively is what is also going to be used by first of our access tables, known as host access table. Host access table is one of the two, I would say, critical ESA components. The other one is known as recipient access table, where in case of HAT, it's basically a set of rules that are used by the ESA to control connecting senders. So SMTP hosts connecting to our ESA in order to relay or originate a message. So we will use this table to determine what of those senders is allowed to connect, and if it is allowed, how the connection is going to be handled. Now, the table itself can be broken down into two sections. We have what is known as a bunch of sender groups, which is what makes our conditions. Sender groups, this is what we will use for classification of the incoming or possibly also outgoing connections. And then mail flow policies, this is going to make our results. So there is going to be a correlation, one-to-one mapping between a sender group and a mail flow policy. And now the table itself is going to be processed top-down until a match is found. And since you can possibly define multiple conditions inside of a sender group, the processing in this case is going to use that mathematical logical OR approach. There is also going to be the default rule at the bottom of the table, which is going to act as a control. And the default action is going to be to accept the connection. So it's like every sender that didn't match any of our, let's say, more specific sender groups will be still allowed to connect and proceed to the other portions of the SMTP server pipeline. Right, let me actually show you this on our ESA. We will take a look at mail policies. We will go down to host access table, and we will take a look at the overview tab. Okay, first thing that you should notice here is that host access table, actually same as the recipient table, is always bound to a single listener. Like this hat, in our case, we have just one listener. Maybe let's go back to network and listeners to show you that. We have just one listener, which is bound to a physical interface M1. SMTP daemon is listening on port 25, and we have one host access and one recipient access table bound to this listener. Now, as I explained in the previous session, it's possible to use more than one listener. Like you would build a listener, let's say one for incoming messages, a listener two for outgoing messages, in which case you would be using different tables, access tables for these listeners. But it's still possible to use a single listener to handle both incoming and outgoing messages, which is what we will do in our case. And that's why only one hat and one red is enough to handle all connections. So going back to the hat overview, this is our sender groups, and this is our policies. So those groups, those conditions will be processed top-down, as I said. We have this default catch-all over here. And as you can see, each sender group is bound to one corresponding mailflow policy. Like whitelist is associated with trusted, blacklist with blocked, suspect goes to throttled, and finally unknown goes to accepted, same as the default sender group. Okay, of course you can add your custom groups. You can modify existing ones. The table in the middle here, sender-based reputation score, it's only showing you one of the conditions that was used or not used inside of the sender group definition. Let me actually open all of these. Maybe let's just focus on these first four. The catch-all is just to match anything else. We take a look at the whitelist. It says this is its name. The order is important. Whitelist is meant to provide exceptions, like specify trusted senders. So it's always evaluated first. This is where you would put your trusted SNTP hosts, like maybe your partner SNTP servers, because as we will see in just a moment, policy associated with this sender group will disable anti-spam and I believe also antivirus checks, which is going to be policy trusted. And in this case, the sender-based reputation is actually not used. DNS list, this is optional stuff to define other types of exceptions, but there is also what's known as a DNS, a host DNS verification. Maybe let me just edit those settings. It's going to make more sense when we open a detailed window. So as you can see here, we have several types of conditions that we can use to define the sender group. And specifically, it's going to be the reputation score. It's going to be IP address or maybe range of addresses defining connecting SNTP hosts. It could be a FQDN or maybe domain of the sender. But this portion is only going to come into play if the double DNS lookup was successful and if the results matched, which means that the sender was verified. Plus, we could also play a little bit with this section, which is all about including senders that were unverified. Unverified senders, it means that one of the lookups, it didn't work, like this option here. We had a DNS failure, or maybe if we didn't find a record for the connecting IP address. And finally, the lookups were successful, but they didn't match. So in all those cases, the sender is deemed as unverified. And the reason why you have those listed here in the sender group definition is that you can simply use these as conditions to include unverified senders in a given sender group. Okay, an important thing to remember about the sender group is that, as I said, all conditions are processed using mathematical OR operation. So the more conditions you specify, the more senders you will eventually catch in a given group. So these options are not used to tell the ESA that those unverified senders are bad. It's just to tell it whether you want to include them in this group or not. And in most cases, when the sender is not verified, it means that it is possibly acting as a source of junk messages. So you wouldn't actually never want to include these checkboxes, mark these checkboxes for the whitelist group, because this one is supposed to define your trusted senders. The reputation score, you possibly also don't want to use this information. This is what you would normally populate with static IP addresses. I'm gonna say cancel. You have that add sender option here. You can put the IP addresses, and as I said, also possibly FQDNs, domains, if the senders are verified. Okay, what's gonna change in the blacklist? Blacklist is by default built based on the reputation score. Let me add it. So we assume that senders that have a really bad reputation from -10 to -3 without the hosts that are not associated with any SPRS, because it could also be the case, like when Cisco doesn't actually know at this point if a given IP address is good or bad. This could happen. We don't want to include those gray senders, let's call it that way. We only want to look at the reputation, which is bad. And this is what we will then associate with the block policy. Okay, next is suspect, which is kind of like in between good or bad, from -3 to -1. And note that whenever reputation score is included in the definition of the sender group, it is also listed here. From -10 to -3, from -3 to -1. Whitelist doesn't use SBRS, so it's empty here. Okay, this stuff is going to be associated with policy called fraudulent. And finally, unknown list is this reputation from not really bad to really good, including the score of unknown. This is why it's actually called unknown list. So those are not actually bad, but they are not 100% sure if they are really good sources. The ones that you know are really good, you put them to the whitelist. So these shouldn't hurt because they have a pretty good reputation, but they also include reputation of none, so it's kind of like in the middle. And these will be also associated with the policy of accepted. Right, sender groups, it makes the first portion of our host access table. The other portion, as I said, is a mail flow policy associated with a given sender group. By default, we have the trusted, blocked, fraudulent, and accepted policies used by the ESA, at least in my case, with this evaluation image. Those could potentially change. I mean, the structure of hat could look different depending on what you configured during the initial setup. But with just one listener and this particular version of the image, this is the default structure of the hat. Okay, so once again, mail flow policies. This is what we will use to control conversation at the mostly SMTP level. You can use hat to define limits, to thresholds, to rate limit connections. You can enable a spam and antivirus engines globally for all incoming or outgoing messages. This is how you can enable encryption, do some other things. But in addition to that, another important thing that you will use mail flow policies for is going to be to classify connections as messages, I should say, emails, as incoming or outgoing. So it's not the listener here what you use to distinguish between incoming and outgoing messages. As I explained earlier, we can have just one listener that is going to be capable of handling incoming and outgoing connections. If you had two, like I would say L1 would be configured as a public listener, which is meant to process incoming emails. And we would have another one for outgoing. So it would be an example of a private listener. It's still not the listener itself what defines whether a message is going to be treated as outgoing or incoming. It's going to be the mail flow policy, specifically one of the two actions what's used to decide how to treat the email. Okay, so let's now take a look at those actions. Continue. This is the only action that is deemed as non-final. The same exact approach like with the web security appliance. When you say continue, it means that you don't know what you want to do with a connection at this point. You want to evaluate the table further. Okay, accept. This means that the connection will be accepted and the message is going to be treated as incoming. But we will still use the error of the access table, recipient access table, to decide whether we want to accept the message or not. In case of the relay action, this is going to be the opposite. I mean, we still accept the connection, but the message is treated as outgoing email, like if this was originated by our internal user, in which case we don't really want to control the message, the session based on the destination, because we assume that our internal users are trusted, so we want them to be able to send emails to anyone, to other internal users and to any external domains, and this is because the recipient access table will not be used. We will take a look at that in just a moment. There is also the TCP refuse option, which is used to deny the connection at the TCP level, so not even allow the sender to proceed to the SMTP conversation. And reject means that you will cut down on the connection at the SMTP level, so the connecting host will at least see the banner generated by the ESA. Okay, if we take a look at our hat, maybe let me first show you the actual policies. Trusted, blocked, fraudulent, and accepted. We have just 4. What's going to be the difference between them? Well, first and foremost, the difference is going to be in the action configured in those policies. Like trusted, it says users accept. Blocked, users reject. Fraudulent and accepted, users accept. So we have 3 mail flow policies configured with the accept action and 1 with reject. Okay, so this stuff, the first 3, this is all for incoming messages. Whenever we have a head here, we will classify a message as incoming. Okay, this one we drop, but we still not have anything for the outgoing emails. Because the listener type that I have configured during the initial setup on this particular platform is a public listener, which is in this case only meant to handle incoming connections. Now, how would you normally define a policy to handle outgoing connections using this single public, in this case, listener? It's actually something that is pretty easy to accomplish. It's all about building one additional sender group and one additional mail flow policy. So I would say add a sender group where I would tell it, I'm going to call this sender group relays, where I will tell it what's the IP address of my internal SMTP server that is allowed to send outgoing messages via the ESA. Okay, so I will call this group relays. I will submit. Okay, the policy in this case is gonna be no. First step, we will have to build a policy. Let's do the opposite. Let's start with the policy and then add a sender. It's not gonna work the other way around. So I have to go to mail flow policies. We will, in the same time, see how to add a new policy. This is the policy list. Accepted block product trusted for. Once I have opened here, I can select the listener, add a new policy, and the policy, I'm going to call it relayed. And as I said, the key thing here is that for outgoing messages, so that policy can read messages as outgoing, the configured action must be set to relay. So the policy name is not important. What's most important is to select relay as the action. The other portion of the policy is all about defining the settings. We will take a look at them in just a second. And since this is for outgoing connections, for trusted messages, messages coming from trusted users, I'm going to just disable the spam, antivirus detection, the encryption authentication. This is by default disabled. Let's also take a look at the limits. Well, I would probably disable all of those thresholds, all of those limits for relayed messages, or just set them to a really high number. So this is something that you have to customize, you have to tailor to your organization. We would just submit. And we'll now go back to the host access table overview to add a sender group and map it to our new mailflow policy. Okay, so again, I'm going to call it relays. No reputation score, no other options. I will say submit. And we will still, I'm going to select the relay policy. Now submit. And we will still have to add a single condition for this sender group, which is going to be IP address of our internal SMTP server, which in my case is going to be this device. 172.16.10.100. And this is exactly how you would allow the ESA to not only handle incoming, but also outgoing emails. Right before I commit, one additional thing I want to do is going to be to reorder the policies in the head, sender groups in the head. The relays, this is something that you should put on the top of the policy. Let's say this is 2, this is 3, this is 4, this is 5, this is 1. Like that, you'll submit. Because remember, relays, it's a connection from your own internal server. So stuff like that you want to process first. You don't really want to possibly match a different group, a different sender group for your internal SMTP server that you use for outgoing messages. So relay first, then whitelist, and then follow the regular default order proposed by Cisco. Okay, commit, and we will be good to go. And going back to the policy options, what's the difference between trusted, throttled, and accepted? Because we know that blocked, this one is configured with reject. So this stuff here doesn't really matter because the session is going to be dropped at the conversation level. Okay, in case of the trusted policy, we see that the connection limits, the message limits, the threshold, and rate limiting in general is configured with pretty high numbers. The default ones are pretty low because it's for our trusted senders. In addition to that, spam detection is disabled. Well, we will still scan those connections with antivirus engines. Our users can still potentially source viruses, like if their stations were infected, but they are not assumed to send spam messages. Authentication is going to be disabled. And there's also that last section at the very bottom here, which is known as envelope sender verification. This is verification of the envelope sender at the SMTP conversation level, like when you say hello and specify your source domain. So the logic here is that since this technique, like spoofing the envelope sender information, is commonly used by junk senders, by spammers, with verification enabled, you will be able to drop the session for all senders which are unverified. An additional level of protection, but by default it is disabled. Okay, what's gonna change in the throttle policy? Okay, so in this case, we will rate limit. We set the limits, thresholds to lower numbers than the defaults. We also cut down on the recipients per hour, spam detection, virus protection. This is all enabled. Authentication encryption is disabled, and sender verification is in this case enabled. And finally, accepted policy, we go with the default options. So still use some thresholds, some rate limiting. Don't use sender verification in the envelope, but use a spam and virus detection. And moving on to the recipient access table, this one is acting more of like at the opposite portion of the connection. So host access table was dealing with senders. A recipient access table is going to deal with recipients, with the mail destinations. The main purpose of this table is going to be to quickly drop messages, emails sent to non-local domains based on the recipient address in the envelope. So it doesn't make any sense to process and forward messages destined to non-local domains unless you want your system to act as an open relay, which you don't really want to happen. We don't really want to waste resources, waste our bandwidth to forward someone else's email. This way also cutting down on any potential bounce messages that should be normally sent to non-existing senders. We only want to handle messages, emails sent to us. One additional note on this table, these checks will only apply to listeners that are meant to handle incoming connections and possibly also outgoing connections, like in our case, when we have just one listener for both. Now, if you go for two listeners, one for incoming, one for outgoing messages, the outgoing messages listener, known as a private listener, will not use the recipient access table because it is meant to deliver messages, deliver emails to any destination, in which case we will not have to perform any type of destination-based checks. Okay, the main component of the recipient access table is basically an entry or a series of entries which define a domain or domains for which we want to accept messages. So we can specify the entire domain as your condition, or maybe use a dot and then specify a domain, which is how you would allow emails to your subdomains. You can be more specific. You can build entries for individual users, for all domains, or at a given domain. You can also specify IP address of the recipient host and use Active Directory for additional verification to check individual accounts within your domain. Okay, the other component of the table is going to be the action that tells ESA what to do with a message sent to this particular domain or user or IP address. We take a look at our recipient access table. It's very simple. This is actually something that is meant to be configured just once. You bound it to the listener. You specify your internal domain, which in our case is example.com, and you tell it whether you want to accept emails sent to this domain or not. I can edit this entry to show you the details. The order is still important because we will process those entries one by one. Tap down until we hit this default all other recipients, which is to block the connection, block the flow, block the conversation. Okay, but going back to example.com, action, of course, in this case is accept. One additional thing you can potentially do here is going to be to customize the response on the, in this case, acceptance of the recipient. I'm going to say that our custom response text will be recipient is okay. We will submit. Commit the change. And maybe let me quickly use switch 1. To emulate SMTP client, we will telnet to the ESA over port 25. I'm going to say hello. We will say that we come from an external domain. And I will say that the mail is coming. This is going to be my envelope sender from John at external.com. This is my email source. And my email destination is, let's say, finance at example.com. Example.com, this is our internal domain, which is configured with the accept action in the rat. So this should be accepted. Did they commit this change? I haven't committed it. Let's do it once again. I wanted to show you the custom response. Let's just do recipient once again. Sales at example.com. And now we see the custom banner is shown by the ESA. Right, so these two tables, this is what makes the two, I would say, most important checks performed by the ESA, because authentication, encryption services, stuff like that, so things that are normally performed down the SMTP server portion of the pipeline, like this stuff here. This is more of like optional features that you can enable use on the ESA. So assuming that the host access table and the recipient access table check are okay, this is something that you can basically use to change the message, but not drop or discard it. So with these two being fine, in most cases it means that you can proceed with the data command. And this is how you would build your message. We see it says message is accepted. We could also take a look at the logs on the ESA to confirm the delivery. But from that point on, everything else, once again, assuming that we didn't configure those additional features, it would normally mean that we would save the message on the ESA's disk and then proceed with the message, put it to the work queue for further evaluation with our inspection engines and other features.